Next week you have midterm break. Okay, there's no class in the next week. So I will finish your class, lectures in the month of November. Okay, and in the next week I will give you some tasks to do, right? Some problems. So you need to do separately. Okay, write your name, enrollment number, and then solve the problems. I will share it.
Okay.
So I was just in the last lecture I was discussing about geophysical application, okay, in hydrogeology. So I already discussed about electrical method, right? How we can use electrical method, electrical resistivity method, as well as SPE method to identify conductive zone, okay, to identify um, movement of plume as well if it is a time. For if there is a contamination, how you can identify where the contaminations are located. Similarly, you can use SP method or resistivity method for infiltration experiment or recharge experiment as well. Okay, so actually recharge experiment is quite tough because for recharge you need lots of basic equations. Okay, if you are theoretically if you are doing a calculating recharge, right? So if mathematically you are trying to calculate recharge, then you need uh, wind speed, all the climate data, right? Wind speed and temperature, what is the sunlight duration, if it is a cloudy day or without cloudy day, everything you need. And it's super complicated to calculate evapotranspiration because this is very sensitive to climatic condition. For example, if the wind speed is high, then your vapor will be saturated uh, air over the surface of the earth, okay, will flow away. Okay, then dry air will come again, it will take water from your soil, so evaporation rate it will increase. Similarly, if daytime or your sun uh, sunny day, it's a sunny day, then also evaporation will be high. If it is a dry season, then your evaporation will be high. If it is a moisture, rainy season or where the air contain lots of moisture, then also evaporation will go down. Okay, so it evaporation depends on um, lots of climatic condition, and these climatic condition is not constant or steady. It changes with time, right? Transient kind of movement is there for within a day as well. So you need lots of huge number of data to calculate accurate evapotranspiration, and that is a super complicated phenomena. Okay, so you are adding, if you are using equation, it means you are adding errors. For example, in your evapotranspiration data, there is error. Similarly, uh, in your uh, what else you need? For example, soil moisture. You need soil moisture data. So then only you could understand how much water will stay there and how much water will move further down. If it's a dry soil, then it will take more water. More water will stay there. Okay, and yield capacity of that soil will be very low. If it is a already moist air, then yield capacity of the water will be high. So some amount of water will stay further, and rest of the amount of water will go for down. Okay, so all these parameters are very complicated because it's quite possible that upper layer of the soil is quite dry, and as you are going down, then evapotranspiration or evaporation rate is quite low, and that is more moist. So you need a continuous data of the soil if it is a dry and or it is a wet soil, okay, moist soil. And how you can get that? If you are taking core from that part, then also you need to take it to observatory, right? And whenever you are taking it to observatory, it will time taking process, and that soil content will be changed, right? So actual data, collecting actual data from the field is really complicated. So if you are adding that soil moisture, it means you are adding further error to your recharge equation or infiltration equation, right? That's why calculating recharge or infiltration using such type of equation is not very accurate. It's always having huge amount of error. Okay, so one of the method, that is a geophysical based method, you can apply and you can calculate what is a recharge rate or what is a infiltration rate. Okay, if the water is moving downward in the vertical direction in unsaturated zone, then it's called infiltration. Whenever it will reach to water table, okay, and it will water, and it will go to whatever water is infiltrating, it will go to saturated level, then it will call recharge. So both the processes are same, and recharge is also depend on infiltration, right? First infiltration will take place, then it will allow recharge process. So it's very important to understand the phenomena, okay, if you are interested to calculate recharge, because if you see recharge, artificial recharge is nothing. You need to find out which area is more useful for recharge process. For that, you need to calculate what is the amount of recharge is taking place in particular place, so that you can plan for a ditch or you can plan for a pond, okay, in that area, so that water can locked at that position and it can infiltrate and then recharge. If you don't have accurate idea of the recharge, then you cannot plan for infiltration or you cannot plan for artificial recharge, right? So all these phenomena are interlinked. So nowadays it is a very popular to use geophysical method, because without disturbing subsurface environment, you can use these geophysical methods to calculate how the water is moving within the subsurface. Okay, how moisture is changing within the subsurface. Okay, how your water table is increasing within the subsurface. All these information you can get using this geophysical method, right? So how, for example, this one, if you see this picture, this is one pond kind of structure, okay, where you continuously, because what happened when natural recharge take place at that time, what happened, that rainfall is continuously falling over area, right? So it is a continuous supply of water to your subsurface. So you need to make such kind of environment for artificial recharge as well, so that water should not flow out. Continuous flow of water towards the subsurface should take place. Okay. So if you see in this picture, what they did, this is the direction, the north side is the direction of slope. Okay, this is the higher slope, and this is southern side is the higher slope, and northern side is the lower slope. So if you have this idea of slope, then definitely you can understand water will always flow towards vertical direction as well as it will follow slope direction, right? So what they did, they make one ditch over the ridge area, okay? And from ridge to valley area, you make these profiles, okay? Electrical profiles. And they try to get data, right? So these are all electrical profiles, so that they could understand what is the rate of recharge as well as what is the direction of recharge. Why the direction of recharge is also important. For example, if slope is very high, okay, then what happened, that gravity will allow water to flow along the slope, okay. Commonly shallow part of the soil having low conductive hydraulic conductivity is quite high, whereas the deeper part having conductivity zone, hydraulic conductivity is quite low. So if there is a slope, then what happened, that high conductivity and low conductivity zone, difference between high conductivity and low conductivity zone, will allow water to pass through low hydraulic conductivity area, okay. So normally shallow surface having weathered formation, right, and that is low conductivity, high hydraulic conductivity zone. So it will automatically, because of gravity as well as because of the high hydraulic conductivity zone, water will follow the slope. Okay. So to understand how much water is subsurface runoff is taking place, it is also important. Then only you could understand how much water is actually reaching you to your aquifer, right? So this geophysical survey, if you are trying to do 3D geophysical survey, right? This is a profile for 3D geophysical survey. For example, at one place, if you are taking survey and then another take with the same distance, okay, then it will call profiling along one direction. Okay. So if we are trying to do sounding as well at one place, okay, with vertical distance, okay, you are taking data with vertical distance, okay, depth wise. And the same next point, you are doing vertical distance calculation, okay. So similarly, for all the point you will do, at all the point you are going to do sounding, okay. And automatically, because you are changing point from one to another, then profiling is already taking place, because you will plan sounding with one depth for the next depth for the next 3 4 level of depth, right? So it means from one depth you already done your profile. For next depth, you need to fix your depth as well, okay. So next level, you are doing already completed your profiling as well as sounding. Similarly for all the lines. Okay, so you have a number of data set. Then when you are planning to plot it, then you need to plot it for a whole area. Okay, then it will give a tree image, contour image, how conductivity, subsurface electrical conductivity is distributed. Okay. So this subsurface electrical conductivity will give you, that range will give you if it is a weathered formation. If it is a weathered formation, then moisture is there or not. Okay, that there is a range of values. Okay, if moisture is there, for example, if you are doing density, I mean gravity survey or seismic survey or electrical survey, okay, all will give you the information. For example, density, if it is a weathered, right? But it is, if it is a weathered but um, unsaturated, right? Then density will be lowest. Okay. If it is a weathered but it has moisture, enough moisture, then it will increase. Moisture will increase the density, because that void space is not empty. Okay, there is a no, that air is replaced by water. So we know that in compared to gas, liquid having higher density, right? So it will give you higher density values. Similarly, if it is a weathered formation, then it on, if it is a weathered, it means high porosity, then small amount of moisture always will be there. Okay, very negligible amount of water. We will call it as a dry, but because porosities are there, then small amount of water always will be there. So it will show a moderate conductivity value, had electrical conductivity value. If it is a saturated with water, then it will show a lower, sorry, conductivity, electrical conductivity value will be high, because we know that water is polarized in nature. Okay, so this polarity increases conductivity, electrical conductivity of the water. Okay, for example, oxygen having negative polarity and hydrogen having positive polarity, right? So this is not exactly balanced, there is polarity, okay, in water molecule. That's why this water molecule having higher conductivity, electrical conductivity values. Okay, so if it is a moisture is high, then your conductivity range will be high. Okay, if it is 100% saturated, your conductivity range will be quite high. For example, 50 to 200, like that. Okay, so we, as the using chart, you can understand what is the range and what could be the material and how much moisture is present. All this information you can get based on these values, right? So this is the governing equations, right? For example, if you are doing survey for only one time, t0 time, right, then it will give you idea. uh, Not t0 time is not enough, because just it will start moving. Okay, water will flow. Okay, so it will not give a better idea. So you, what you need to do, you need to do time depending transient survey, right? Time depending survey. For example, because you are interested to know how the water is flowing within the subsurface. Okay, whenever you are interested in flow, then you need to do time dependent survey. Okay, then it will, because flow always take time to move from one place to another place, because it is subsurface flow, so it will require more time. For example, commonly we put in about 7 hours interval or 12-hour interval, and we select 4 5 interval points. Okay, 40 up to 48 hours we go, we do survey. Okay, to see how what is the recharge rate, right? What is the time it will reaching the water table. Okay, so because it is time dependent, so it will give you the idea what distance it has already moved. Low conductivity zone, your water will be low conductivity zone, so it will give you idea up to what distance it already moved. Okay, that is the distance. And at what time, because time is fixed by you, it could be interval of 7 hours. So this distance as well as time will give you the velocity. Okay, rate. Okay, so you can calculate what rate, what is the rate of recharge, or what is the velocity of the water flow. Also you could understand how this, for example, if you see this picture, right, so this will give you idea. So recharge is taking place from this point. So not necessarily all the area is good for recharge, right? So you need some area. For example, there could be boulders or some high resistivity zones are there. For example, big boulders are there, or some rock structures are there that is not porous in nature. That will, so at that place recharge will not take place properly, right? So whenever there is a space or fractures or weathered formation open to the atmosphere, okay, open to the environment, at that place recharge will take place. Okay, if you see the recharge is limited to this area, okay, this area, its color is also showing that is a highly moistured weathered formation. So water is flowing. Okay, you can see the direction of water. This is 2D. If you have more number of data in the other direction as well, then you can match that data how the water is moving. If it is moving in vertical, I mean horizontal direction, or along the slope, every information or how much time it's taking, all the information such kind of investigation will give you. Okay, so this is the equation. uh, for example, this is a simple equation, like already we have discussed about flow, right? Static flow, hydrostatic flow, as well as transient flow, right? So similarly, electricity also flows from one point to other point. Like we use diffusion equation for flow of electricity, we use diffusion equation for flow of water, we use diffusion equation for flow of heat as well. So any flow you can describe using diffusion equation. Okay, so simple Poisson equation you can use here. In a steady state condition also, or sorry, groundwater flow equation also, we are use Poisson's equation only. Okay, differential equation, that is. Okay, and when your Poisson equation will be Laplace equation when it's a steady state flow. Okay, when one side, this not time depending, one side will be 0. Okay, so same equation, if you see this equation, that is the same equation we are using here. Okay, and this is, if you see the first equation, that is nothing, that is that this will give you the flow. Okay, for example, this is electrical uh, for example, if this is a row of density of water, right, g is what, G is the acceleration due to gravity. This is H is in meter, hydraulic head, or Z is this is a datum. Okay, from the datum. So this is flow equation, water equation, right? Hydrostatic fluid pressure. This is pressure is this one, P is this. So already we have discussed it earlier. Okay, how we will calculate hydrostatic pressure of the water. Okay. So to calculate, to relate this flow with this electrical flow, because here what we are doing, using this conductivity, this is nothing that is a, you can use Coulomb's law to understand this, what is the conductivity values here. Okay, so this is the conductivity values, hydraulic conductivity value, electrical conductivity, and we are assuming this electrical conductivity value is very similar to the groundwater flow, okay, subsurface flow of water. Okay, so why we are relating both the pictures similar way? Because we know both are flowing, okay, from one place to another place, both having the similar equation, set of equation. Okay, behavior of groundwater flow and electrical flow are same. That's why we can relate it, right? That's why I'm showing you the equation. Just picture will not tell you, because we are scientists, so we need, our language is always mathematics, right? So picture is not enough to tell anything. Why we are doing two things at the same time? That is important. That to explain this, we need some equation. So these are such equation. It will tell you we are using same diffusion equation, we are using same Poisson equation, and it will tell you how the flow is taking place. Groundwater flow is taking place using the same concept, right? So, so experiment soil is, so it could be anything. For example, in this experiment, soil is carbonates, siltstone. So using this electrical survey, you can at the zero time, then when flow is not taking place, you can get information of the subsurface formation as well. So at zero time, when flow is not taking place, you can get all the subsurface geological information, and then after, with time, you do the further surveys, okay, with time interval, and you could understand how the flow is taking place, water flow is taking place within the subsurface, right? You can calculate porosity as well using these equations, right? There is one equation that is called Archie's equation, okay? You can search it, Archie's equation. Archie's equation will give you relation between porosity as well as resistivity, subsurface resistivity, okay? So if it is a clay-free zone, okay, then you can use Archie's equation to calculate porosity, right? So one electrical survey that is not very uh, costly, because same instrument you can use for point to point survey, okay, and also it's not going to disturb your subsurface environment, right? So you can use one survey to calculate or to understand what is the subsurface geology, what is the thickness of your aquifer system, okay, what is the depth of your water table, as well as what is your porosity, okay, how what, what is the porosity distribution, as well as if you are doing the same survey with time, then you can calculate, or you can understand, or you can calculate the recharge rate, infiltration rate as well, okay. So many things you can calculate using one simple method, right? So you could understand how important it is, okay, and how useful, not important, how useful it is, okay. It is saving your time, it is saving your effort, okay, it is saving your money, and it is capable to give lots of information from the subsurface, right? So this is your electrical potential with time. So this kind of data set will give you how the flow is taking place with time, because you are doing time dependent survey, okay, to understand the flow. So this potential distribution with time, okay, from at one point. So this is also electrical potential difference distribution with time. For each point, you can calculate and you can understand how this is going to vary from place to place. Okay, so these are the contour maps. Okay, that is going, it's showing you how these conductivity values are varying. Okay, with time. For example, it's 60 seconds, it's 10 minutes. Okay, sorry, it's a 10 minutes, it's a 60 minutes. So this is very small change. Okay, if it's a very, so this formation is quite high porosity and permeability. That's why you can see within a small interval as well, you can see there is a change in hydraulic conductivity or flow is taking place. If it is not very weathered or very high conductivity, okay, it is actually a limestone formation and there is a sinkhole. That's why you are able to see so fast movement. Okay, because sinkholes are always secondary porosity formation are always high conductive zone. Hydraulic conductivity is quite high. So that's why you can see within a small time interval how fast it's moving. But if it's a alluvial formation, then you will find the movement is quite low. Okay. Similarly, you can calculate recharge as well. Okay, infiltration as well as recharge, same way, right? So these are the equation, recharge equation, right? So this, if you see these equation, you will find this depends on infiltration rate, this depends on hydraulic conductivity, it depends on a time, infiltration capacity, and this infiltration capacity also further depend on evapotranspiration, moisture content, all these things. So if you are using mathematical equation like this, then it's a right very complicated as well as uh, error factor is quite high. Okay. So geophysical methods are excellent for the application because of their scalability. Scalability means you, if you are doing other survey, for example, if you are taking samples from subsurface, okay, for isotope survey or anything, then it is a not continuous survey. It is a point specific survey. Okay, for example, if we are taking isotopes to calculate recharge, then we need to select few points to take the samples, right? But it could be possible that you actual what is the most dominant site, you could miss that, okay? Or important site, you could miss that, right? Because that recharge is not only vertical movement, it is also direction specific. So 360-degree direction it could move. Okay, we are thinking it should follow the slope, but not necessarily it will always follow that slope only, because it depends on the movement of water, depends on definitely slope, but the slope area is hard rock formation, it does not have enough porosity. Okay, then it would not allow water to pass through it. Then definitely water will flow somewhere, it will follow the other direction. Okay, so similarly, if your water is clay, slopey side is clay for high clay content, then again it will not allow water to flow, so it will flow from other side. So when we are talking about groundwater flow, it's not so simple. We need to understand lots of things. So in if we compare with other methods, that is the point specific methods, right? Then in compared to that, geophysical method is not point specific. It is a continuous survey you can do up to few. For example, if you are using number of electrodes, so or number of big instrument, right? Then you can go up to few meters, 200 meters, right? If you are using uh, like electrical method or seismic method, okay, you can at the same time you can cover a large area, right? So electrical technique are very sensitive to groundwater or subsurface investigation, because this is cheap. Instrument is cheapest one. Okay, gravity is also cheap, but flow you cannot get from the gravity very accurately, right? But you need to do then time dependent. There is a not so such big instruments are present is still there, so that you can at the same time you can cover a very large area. Okay, so seismic and electrical having such kind of instrument. Okay, so at the same time you can cover a very large area. For that's why this 2D and 3D survey are very easy for seismic and electrical method. But in compared to seismic, electrical techniques are cheaper, right? So so this is so these are the method you can use. For example, in the large area you can distribute these uh, signal I mean receivers, and then you can pass electrical current, and these receiver will collect information from the subsurface. Okay, so in case of electrical resistivity survey you have to pass current. Okay, in case of seismic survey there also receivers are there, you need to pass uh, vibrations. Okay, seismic source, this is a trench where you will allow flow of water, right? So this is a movement. For example, this is a conductivity zone, time depending conductivity zone. Okay, earlier you can see there is a very small, then next you can see there is a small change. Okay, and slowly it's moving downward continuously. Okay, so this is a large picture, so it's not a, so this will give you a very good idea how this water is flowing. This is a, okay, so this is a potential versus conductivity. Okay, so if you see this, this is a tracer. If you can put tracer as well, for example conductive tracer in the water also you can, then it will give a very good idea. Okay, for example if you are interested to see how water, surface water is moving subsurface. Okay, both are water, so how you can understand which one is surface water, which one is groundwater? In that case, what we commonly do, we put some salt in surface water so that the conductivity of surface water will be lower. Okay, sorry, higher when compared to the groundwater. Sorry, okay, electrical conductivity of the surface water. So whenever it will move further, for example, like that. Okay, if surface, this is a surface water, high conductivity zone. Okay, so it will move downwards, so it will give a very very good subsurface image how this surface water is moving within the groundwater system, aquifer system, right? So in that case, if you are comparing with water to the water, then you can use salt as a tracer, right? And advantage of salt is that the hydro, it has a low resistivity, high electrical conductivity, whereas the movement of salt is, it mix very well with water, and the movement of salt is very similar to water. Okay, both having the same movement. Okay, so you can use a diffusion equation, same for both the case. You need not, for example, if the movement is different, then in that case you need a separate equation. Okay, but in that case you don't need any separate equation, right? So this is advantage. Okay, so this is a tracer and this is a water. If you see electrical conductivity, okay, of the water, then you will find that these are very very similar, the movement are very similar. Okay, this is how you can see the movement, right? Similar kind of image you can get using the seismic survey as well. Basically we use seismic refraction survey. Okay, that is a shallow depth, very useful for shallow depth investigation. Okay, just here you are getting information about electrical conductivity. If you are using seismic refraction or seismic survey, then you will get information based on the density and anomaly. Okay, it would be high density zone, whereas the surrounding will be low density zone, like that. Okay, you know the salt having high density. Okay, so these are all the images. Same thing. What's the time? So I want to finish this. So another method is gravity method. Nowadays, gravity method is also popular because it will give you uh, density variation, okay, over the surface. Okay, so nowadays, if you see, what is the concept of gravity survey? I'm not written here. Okay, this is a very simple concept. For example, we calculate what is the change. For example, if you see the Newton's first law, then you will find there is a how we can calculate G. Okay, capital G. That's the constant, universal gravitational constant, right? That is m into m is the mass, small body mass, and m, capital M, is the mass of the Earth. R square is the distance between them. Okay, that is the force is equal to, and the proportionality constant is capital G. So everyone must know this is a very basic equation. From there, we can calculate small g, acceleration due to gravity, as well. So actually, when we are using this gravity method, then actually we are calculating acceleration due to gravity. Okay, so we are assuming that acceleration due to gravity is kind of constant, right? But actually not. If you see the acceleration due to gravity from pole to uh, equator, right? You will find that acceleration due to gravity is changing from pole to equator. Okay, so this is changing with time, right? With distance as well as. Okay, so why this is changing? Actually, from pole to equator, the acceleration due to gravity is changing because of its structure, right? Because we know that pole is flattened, okay, whereas the equator is bulge shape. So it means what? If there is a change in structure, then it will show you different value of acceleration due to gravity, right? So gravity method will give you very good understanding of. One second. One. Yes. So if there is a change in shape, then you can your acceleration due to gravity will change, right? So if there is any high density material, right, then shape means what? There is a extra mass. Okay. So extra mass is somewhere that is going to affect your gravitational force or acceleration due to gravity, right? It means if there is some high density material, extra mass is there, so it will affect your acceleration due to gravity. So you need very sensitive instrument to calculate this. So we calculate it in terms of microgals or milligals, right? So you could understand how sensitive your instrument should be. That's why we need to handle such an instrument very carefully, right? So the total water storage change in the subsurface is a key component of global, regional, and local water balance, right? It means balance means it's flowing from one place to other place. It means there is a change in mass. Okay. For example, if there is a huge amount of abstraction of water, okay, pumping is there. So it means there is a change in mass within the subsurface. Water is moving out. Okay. So water is nothing, that is a mass. mass is moving out from the subsurface. So you can calculate how much amount of water is moving out from the subsurface using this gravity method, right? So there is a two types of instruments are present. One is absolute gravity meter, and other is relative gravity meter. So commonly for geophysical application, we use relative gravimeter because we are interested to know what is the relative change in gravity. Okay, gravitation, I mean small g. Okay, so absolute gravimeter are based on your simple spring or pendulum based, what we have already done during our 12th class experiments, right? That was absolute gravimeter, nothing else. But relative means we are comparing one location to the other location, okay? How your G is varying from one location to the other location. So that del G, your instrument will calculate. For example, at location 1, you are getting some G value, okay? At location 2, you are getting G2. So what is the difference between G1 and G2? That is del G. So actually, we as a geophysicist, we are interested to know anomaly, right? So we are interested to know what is the value of del G. So that's why we are using relative gravimeter. Okay. So you can identify how much change in storage of water using del G. So one experiment in Denmark area they did, okay, they try to use gravity as well as they try to use electrical as well as they try to use temperature sensor to understand how this lake water is mixing with groundwater or other streams. Okay, because why they use temperature? Because this is static lake water, means static water. Okay, movement of water is quite low because streams are there. So streams are recharged with this water. Okay, so this temperature could be similar, but groundwater temperature will be higher. Okay, so there is a temperature contrast anomaly is there, temperature anomaly is there. So that a temperature anomaly will give you idea how much water mixing is there in groundwater as well as fresh water. If this lake is recharged by groundwater, okay, then if we are putting this sensor along this boundary, temperature sensors along the boundary, you will find there is a temperature is not similar to the temperature that is present in lake. Okay, there is a change in temperature values. Okay, it means that is affected by groundwater. Okay, so it will give you idea how much mixing is taking place. Similarly, they use electrical survey as well to understand how this movement is taking place. Okay, they calculate what is the conductivity, electrical conductivity value of lake and what is the electrical conductivity value of fresh water. So based on this commonly electrical conductivity value of lakes are more because they are mostly these lakes are contaminated, okay, open to the atmosphere, and that's why they become more acidic, okay, in nature. So if there is a good contrast, then you can get idea without using tracer also, you can get idea how the mixing is taking place. Okay, and gravity, so it gravity anomaly also will give you the storage information, how much water is moving in or how much water is moving out as well. Okay, so for example, if groundwater gravity value is something different here and something different here, then this change anomaly will give you idea how much recharge is taking place at that point and how much is moving towards the other directions, right? So not only this, there is another technique, right? GRACE, that is called gravity based instrument. Okay, that is a satellite based instrument. So using that, that is a super sensitive instrument. Okay, that is time lapse method. So what GRACE is doing, GRACE is a gravity instrument that is satellite based instrument, and using satellite we can calculate how much density is varying. okay, over the particular area. We need to fix that area, and we can calculate how much density is varying with time. So this is a time depending. You can fix interval. Okay, this T1, T0, T1, T2, T3, like that. You can fix the interval, and you can find out how much time it is taking to change the uh, uh, density. So that density could be due to other factors as well, if the formation are undulating. So you need to do corrections, okay, lots of correction when you are using gravity method, because these gravity values are very sensitive, okay, very small values. So you need to bring out actual values that is actually affected by the gravity, that is a change of mass only, right? So what you need to do, you need to check it out if it is affected by uh, undulation of the formation, or if it is affected by tides, the gravitational change due to the sun on moon. Okay, it's affected by uh, other factors, for example, elevation, or we know that is at the center, at the surface of the earth. Surface of the earth mean sea level. Okay, the maximum gravity value you can get. Then if you are moving up, okay, it means your gravity value is, you are losing your gravity value. So such kind of lots of other correction you need to do, and then you can find out what is your actual interest. Okay, what is the signals that is your actual interest. So using lots of correction or lots of interpretation and prediction, you can calculate what is the change in density due to water, okay, storage. For example, continuously in Indo-Gangetic Plain, continuously uh, pumping is taking place. Huge amount of pumping is taking place because of agriculture, because of drinking purpose, because of industrial purpose. Okay, huge amount of groundwater exploration is taking place. Okay, groundwater development is taking place. So that is responsible for change in storage. Okay, this groundwater level is already moved down below the dynamic level of the groundwater. So already static level, they have going down further below the static level, right? So groundwater mining is taking place. So already using this GRACE data, we have calculated that this storage of groundwater in the Indo-Gangetic Plain is changing or depleting very fastly, right? This is alarming condition. So all this geophysical instrument can give you very, very good idea of the subsurface information. So already we have discussed about seismic method, how we can use seismic method for groundwater exploration. We have discussed about the electrical method. We have used the gravity method. Also, we will discuss about the last one, that is GPR, ground penetrating radar. So in GPR, we are using electromagnetic method. Okay, electromagnetic method is very simple method. Just you must know. Okay, these are, I'm not going into the details of the basics of these methods because it's very time taking, and all these methods, the concept of these methods are very simple. Okay, are we on the 12th class standards concept, but when we are dealing with an heterogeneous subsurface environment, actually processing is really complicated. Processing of the data, because there you can get lots of noise. So you need to select your data, and you to I mean clean your data from unwanted data sets, right? So this process is very complicated, but basic concept is very simple. Electromagnetic concept, I believe you must know. Faraday's law and these simple laws are there. Okay, how your electric current, if current is passing through the coil, then you will generate a magnetic field perpendicular to the coil. Okay, that is a right hand rule. So we already read during 12th class standard. Okay, so you just refresh, you read about electromagnetic methods, this all this method, and this seismic method is very similar to the optics. Okay, we already read about the optics. So all these methods are very similar. Refraction, reflection, all the concepts are very similar. Okay, so in this GPR, what actually we need one transmitter and we need one receiver. TX is the transmitter and RX is the receiver. Two-way travel time when you are transmitting using this antenna. When you are transmitting your signal, antenna means see this having one coil. You are producing some allowing current to pass through this coil. Okay, so whenever you are passing current through the coil, then in the perpendicular direction, it's generating current. Sorry, magnetic field as well. Okay, so why this is a two-way travel time? Because these currents are not DC current; they are alternating current. Okay, so it's changing its direction from one direction to the left to other direction. Okay, so that's why these are two-way travel time. So if your material is highly dense, then receiver signals, these blue lines are the receiver signals, red lines are the transmittive signals. Okay, if you have a conductive zone below the subsurface, then it will catch that magnetic field. Again, that magnetic field will generate some current that is called AD current, right? So again it will generate some current, and that current will come back to your receiver. Okay, so this receiver that you are collecting will check it out what type of subsurface formation is there based on the amplitude of the signals. Okay, so if this is a high dense material, then amplitude will be good. If it's a low dense material, then amplitude will be small. Okay, so GPR, for example, this one, these are the signals, receiver signals. so so you can use this method as well to calculate sorry, calculate groundwater properties. Okay, as well as what is the subsurface properties as well, what type of formations are present. So we have discussed broadly about the geophysical method. Oh, sorry. How we can use these geophysical methods. Okay, so I will share the slides very soon. You please read the basic concepts. Okay, any question? Okay, so next week is your midterm break. So after that, we will again discuss about the groundwater chemistry and then groundwater management. Groundwater management part is super simple. So I will give you a brief introduction and then I will give you some document to read, right? So not next Thursday, next to next Thursday, we will again discuss, okay? Okay.